Well, now we're going to do some simultaneous equations, still in this chapter that deals with equations and inequalities, okay? And question 1 says, determine the value of x and y, which satisfy the following system of linear equations. Now let's start with A. We have like x minus y equal 2, and 2x plus y equal 10. So I'm gonna write them like this, 2x plus y equal 10. I prefer to label my equations, like call it like equation 1 and this equation 2. Then I can do, in this case, I can just add my equations, because why doing that? Because over here, I can cancel the two variables, okay? To solve the equation simultaneously means we need to find the value of x and y, as the question indicates here. So over here, I look at I have a negative x and positive negative y and positive y. So if I add the two equations, the equations will become 3x. These two will simplify, okay, equal 12. Now to get the value of x, I can just divide here by 3, here also by 3. Then we'll get x equal to 4. Now that we got the value of x, we can substitute the value of x in either equation 1 or equation 2, okay, to find the corresponding y value. So this will be, so it's going to be x minus y equal to, if I sub in equation 1, x is 4, okay. I'll move y over and then 2 over, okay. So this will be 4 minus 2 equal y. Then that means y is just equal to 2, okay. So these are the solution x and y. That was question A. For question B, for instance, so now you notice that we have like a different way of solving simultaneous equations. It can be by elimination, or sometimes called cancellations, or it can be by substitution. Okay, so it depends on, in this case, I thought this method of cancellation or elimination was easier. I think so, but someone else can use, we can use any method. Like in this exercise, I can use any method that is, I think, suitable to a certain problem. Now, I look at this question B here. There, when I look at the terms, I don't see that I can cancel certain variable easily. In this case, I prefer to use a substitution method. So I'll move negative 3x over, and then this will become from this is equation 1 and that's equation 2. So this will become what? Y equal to 3x minus 2. Okay. From equation 1. Okay, let me write this way. Okay, yeah, let's just call this one equation 1 and that equation 2. Now from equation 1, okay, I said I can move the 3y over, the 3x over, the negative 3x over. So the equation will become y equal to 3x minus 2. Okay. Now we can sub 1 in 2. Okay, so this will become, instead of me writing from equation 2 here, instead of me writing like 7x minus 2y, I'm gonna write, okay, let me first illustrate it. It's like 7x minus 2y equal to 8. I am gonna write 7x minus 2, okay, equal to 8. Instead of me writing y, I want to sub in the value of y, which is 3x minus 2. Now, this will be written as 7x minus 6x, because we times here, this with that, and that with that, minus 6x, and then plus 4 equal to, I'll move the 8 over, so it becomes negative 8 equal to 0. Now this will become what? 7x minus x, 6x makes x, and then 4 minus 8 makes negative 4 equals 0. Now this, which means that x equal to 4. Now that we got the value of x, okay, we can just substitute this value in equation 1 here, okay. So now from 1 then, which was now y equal to 3x minus 2. This will become y equal to 3x minus 2. Accept the value of x, which is 4. Okay. And then y will become 12 minus 2, which is 10. Now we got x and we also get y. Okay. Now, question C, I can label them like equation 1 and equation 2. And I can see that here, because we have like negative 2y, we can move this 2y over, okay? And then I think I can see use a substitution method here. So then let me write. C are the equations are like 3x plus 5y equal 8, and x minus 2y equal to negative 1. Now, as I was saying, we can move the negative 2y over, okay, from equation 2. So this is equation 1 and that's equation 2. Now, right here, equation 2, which is given by, will become then x equal to 2y minus 1, okay? Now, I can get back into equation 1, substitute that in equation 1, instead of me writing like 3x, I'm gonna write 3x plus 5y equal 8. Then assign the value of x, which is 2y minus 1. And that makes, okay, maybe it should be a sub in 1. Okay. Then this becomes like 6y minus 3 plus 5y equal 8. Okay. 6y plus 5y makes 11y. And then if I move the negative 3, this negative 3 over, it will become positive 3 there. 8 plus 3 is 11. Now we divide here by 11, and there also by 11, and then we get y will be equal to 1. Now that we get the value of y, we can just substitute that value of y over here. Now we can sub y equal 1 in 1, okay? This will become not in 1 but in 2. And then this will become x equal to what? 2y minus 1. Y is 1, and then that means x will be equal to 1. So these are the value of x and y. So solved simultaneously. Okay, we can also do question D. D is given by 7x minus 3y equal 41, and 3x minus y equals 17. So if I call this one equation 1, that I call equation 2, I still prefer to use a simultaneous equation here because I can move y over and then 17 also over. And then equation 2 will become what? 3x minus 17 equal y, or just y equal to 3x minus 17. Now, from here, I can now sub 2 in 1, okay? And then this will become what? 7x minus 3y equal to 41. I sub in the value of y, which is 3x minus 17. Now this will be 7x minus 9x plus 51, okay, equal 41. And then that will make 7x minus 9x is negative 2x equal to 41 minus 51. That means negative 2x equal to negative 10. That means when we divide both sides by 2, negative 2, we get x is equal to 5. Now that we get the value of x, we can sub x equal negative 5 in 2. Okay, and then this will be y equal to 3x minus 17. So that's 5 there, and then this will be y equal to -2. So we got the value of x and y solved simultaneously.